Hey everybody. So the last couple of days we have spent dealing with this concept of proving identities. And we've only taken you about of a third of the way down your full identity list. Remember that I said we were going to stop for a little while and just practice proving. And so we've only taken you down to the end of your Pythagorean identities. What we're going to do today is we're going to add in the next 6. Now, all of these collectively are referred to as sum and difference of identities. And so what you'll look at is there's 2 for sine, 2 for cos, and 2 for tan. And they all involve a plus b, or on your formula sheet it says alpha plus beta, but that means the same thing. So a plus b or a minus b. So we're looking at how we can add 2 angles together or subtract 2 angles from each other and create another identity. Now, you don't have to know how these identities got created. Our goal is just that you use them. So they are on your formula sheet for you, and you can use them at any time where you see fit. Now, what you're going to notice is where you see you want to use them is when you are given an angle, specifically when you're given an angle and it's not on the unit circle, but then you can use 2 angles, add them together or subtract them from each other, and the 2 that you're using are on the unit circle. That's where these guys come in handy. But I'm getting ahead of myself. We'll get there in a few minutes. So the first thing I want you to do is just take note of what the identities are. They are listed on your formula sheet. I do have them here. So it says when we want to examine exact values of sine theta, cos theta, and tan theta, where theta is not on the unit circle, we can use the addition or subtraction identity. So again, this is essentially just another tool that we're now going to start working with when it comes to identities. If you want to pause me and write these down, that's great. If you want to just take them from your formula sheet, that's fine too. But essentially it says sine of a plus b, a reminder your formula sheet says alpha plus beta. That's fine, they mean the same thing. Sine of a plus b is sine of a cos of b plus cos of a sine of b. Sine of a minus b is sine of a cos of b minus cos of a sine of b. Cos of a plus b is cos of a cos of b minus sine of a sine of b. Just be careful with cos that you're actually writing it down correctly. You'll notice here the addition one actually involves, oh, sorry, I didn't mean to do that. The addition one actually involves subtraction. And then the subtraction one, cos of a minus b, is cos of a cos of b plus sine of a sine of b. So the subtraction one actually involves addition. So just be very, very careful when you go to write or you go to use cos that you're actually writing it down properly. Then the tan of a plus b is tan of a plus tan of b all over 1 minus tan of a tan of b. And then tan of a minus b is tan of a minus tan of b all over 1 plus tan of a tan of b. Again, with tan of a plus b, just notice that when it's addition, you are adding on the top and subtracting on the bottom. And when you are subtracting on the top and adding on the bottom. So just make sure you're writing it down. It really sucks if you find out you just actually wrote the formula down wrong, because then the rest of the question is wrong. So just be very, very careful that you do write it down correctly. Okay, so how do we use this stuff? Okay, well, first question I have here is determine the exact value of the sine of 75. Now, the first thing I want you to see is it says the exact value. As soon as you see exact value, that means you're not allowed to have decimal answers, which means you can't just plug sine of 75 in your calculator and write down whatever random decimal you see. So that's the first thing you need to think of is, hey, probably need to use my unit circle here. The second thing you need to think of is, hey, 75 degrees is not one of those pretty ones that we looked at when it comes to our unit circle. A reminder, there are an infinite amount of points on the unit circle. We happen to look at a few of them that they allowed us to get those exact value answers, okay? So just because 75 degrees is not a pretty one, it's not on the unit circle, as those pretty ones, it is on the unit circle is what I'm trying to say there. Anyway, what you want to think about then is, hey, let's look at those pretty ones on our unit circle. This is a great lesson to have your unit circle right beside you so that you can refer to it as we go. What is on my unit circle that I could add or subtract from each other and get 75 that way? And what you'll notice is you've got 30 and you've got 45. So if you've got 30 and you've got 45, I can say that the sine of 75 is the same as the sine of 30 plus 45. Now, why would I do that? Because that's now a sums and difference identity. That's the sum identity for sine. So I'm going to switch sine of 75 to be sine of 45 plus 30. Now, in your own work, you may want to actually put a little alpha up here and a little beta here, or a little a up here and a little b here, just so that you remember to keep things straight. It's not as bad when you're adding them, but you want to make sure you know which one is alpha and which one's beta, so you don't start reversing things and getting a different answer. Okay, so I head to my formula sheet. Sine of a plus b is sine of a cos of b plus cos of a sine of b, which is this. I just plugged in everything I was told to. There was no thought there. All I have done is I've transcribed it from my formula sheet. But now what I need you to see is each one of these are ratios that you know. You know the sine of 45. If you don't, you can look right off the unit circle. You find that it's root 2 over 2, or that it's 1 over root 2 if you have an unrationalized version of your unit circle. You know that the cos of 30 is root 3 over 2. You know that the cos of 45 is root 2 over 2, and you know that the sine of 30 is 1/2. So in this next line here, all I've done is I've taken each one of my ratios, or each one of my angles, and I've figured out what that actual ratio is. This next line is just about the ratios. The sine of 45 is root 2 over 2. So I've replaced the sine of 45 with the ratio that it equals, which is root 2 over 2. And I've done that for each one of the 4 that I was given. Well, now I just do the math. Here I'm multiplying fractions together. I multiply the tops, multiply the bottoms. Root 2 times root 3 is root 6, and 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is 4. So I'm left with root 6 plus root 2 all over 4. Now, if you wanted to check your answer, take your calculator, go sine of 75, make sure you're in degree mode when you do that, but take your calculator, go sine of 75, figure out what that random decimal is, then go and use your calculator and figure out what root 6 plus root 2 all over 4 is, and you should get the exact same decimal answer there, because they're the same thing. Okay, the nice thing about it though is this is the exact value. There is no rounding error here. So the sum and difference identities allow us to get to this whole other set of angles where we can still use exact value. We can still get exact value answers, even though they weren't readily shown to us on the unit circle that we talked about. Okay, the next one. The exact value of the cos of 15 degrees can be written in the form root of a plus root of b all over c. State the values of a and b and c. So same question, except now instead of just stating the answer, you have to say what is a, what is b, and what is c. But it looks like it's going to end up being in the same sort of a format. That root a plus root b all over c should look familiar to you just based on the answer you just did in the first question. Okay, so 15 degrees is not on our formula sheet, or sorry, that's not what I meant. 15 degrees is not on our unit circle. So we're looking for two numbers that I add together or subtract from each other that I can find on my unit circle. And so most of you are looking at your unit circle. You've probably decided by now, hey, we can call that, I don't know what happened there, sorry. We can call that 45 minus 30. So I'm going to take cos of 15 degrees, and I'm going to change it to cos of 45 degrees minus 30 degrees. That is now cos of a minus b. So I head to my formula sheet. Again, you might want to write a little a or b on top of the 45, a little a on top of the 45, a little b on top of the 30, or alpha or beta or whatever, but make sure you're not mixing these guys up. So cos of a minus b is cos of a cos of b plus sine of a sine of b. And so I fill that in, cos of, remember that my a is 45 degrees, so cos of 45, cos of 30, plus sine of 45, sine of 30. These are all just ratios that I know. So cos of 45 is root 2 over 2, cos of 30 is root 3 over 2, cos of 45, sorry, sine of 45 is root 2 over 2, and sine of 30 is a half. I'm right back to where I was in the previous slide. I do the math here, multiply the fractions together. This is going to give me root 6 over 4. This is going to give me root 2 over 4. So my final answer is root 6 plus root 2 over 4. Now, a couple of things. I haven't concluded yet because this said what are the values for A, B, and C. So I do need to give a concluding statement that says, okay, A is 6, B is 2, and C is 4. Now, a couple of things I want to say about this one. First of all, just in case you're freaking out a bit as to how do I know which one was A and which one was B, you don't. If this was a numeric response question on a diploma, they would say, hey, A and B are interchangeable. So they'd accept the answer 624 or they'd accept the answer 264. So don't worry about that. Probably they wouldn't do that to you on a diploma though. Probably what they do is one of these would end up being like 3 root 2 or something like that. And then that way it can distinguish as to who exactly is A and who exactly is B. The second thing I want to talk about is I want you to notice that this is the exact same answer that you just got with sine of 75 degrees. That doesn't mean all these answers are the same, but 15 and 75 are complementary to each other. Complementary means they add up to 90 degrees. 15 plus 75 is 90. There is a trig rule that says complementary angles for sine and cosine will always equal each other. So in this example, I gave you sine of 75 with cos of 15. That tells you that the sine of 60 has to equal the cos of 30. Tells you that the sine of 5 degrees has to equal the cos of 85 degrees. So if those two numbers add up to 90, if they're complementary, the sine and cosine will always be the same value. Okay, good. So now we're going to try tan one. Now I purposely have chosen, there's a bunch of different ways you could do this tan one. I've chosen probably what will be a slightly more complicated way, just because I want to walk you through some of the math. So it says the exact value of the tan of 105 can be expressed in the form negative a minus root b. And again, we're being asked what are the values of a and b. So I need to have two numbers that are on my unit circle that I either add together or I subtract from each other. Some of you may look at this and say, hey, right away, let's do, I don't know, 60 plus 45, and let's do tan of a plus b, because 60 plus 45 is 105. Great. You can do that. You're going to get the exact same answer. Again, I want to walk you through one that's just a little bit more complicated, so I'm going to do a subtraction one. I'm going to choose to do 135 minus 30. So I'm going to break this into the tan of a minus b. So I look at my formula sheet. I know that the tan of a minus b is going to end up being tan of a minus b is tan of a minus tan of b all over 1 plus tan of a tan of b. So I do that. And now, again, I have to figure out what each one of these ratios are. Now, tan of 135, remember, if you're on your unit circle right now, 135 is right over here. And that is negative root 2 over 2 comma root 2 over 2. So a reminder that when you're dealing with tan, it's always y over x, or sine over cos, if you like that better. Anyway, what I want you to see here that these are the same number, except one is positive and one's negative, so that's going to equal negative 1. So you've got a tan ratio there of negative 1. Tan of 30, we're over here for a second. The tan of 30 degrees, the coordinate point at 30 degrees is root 3 over 2 comma a half. So the tan of 30 degrees ends up being, again, y divided by x, or sine divided by cos, 1 over root 3. I'm just going to rationalize that and call it root 3 over 3. Okay, you don't have to rationalize. If you want to leave it as 1 over root 3, that's totally fine too. Okay, so I'm going to plug in those ratios. So I end up with negative 1 minus, what's going on there? Sorry. I end up with negative 1 minus root 3 over 3 all over 1 plus negative 1 times root 3 over 3. So now I want to clean this up a bit. This top part here that I'm circling with my mouse, I want to make sure that becomes one fraction with a common denominator. So I'm going to call my 1 here 3 over 3. So then I have two fractions that are both over 3. Here, this is going to be negative root 3 over 3 when I multiply those guys together. And I'm going to call this one 3 over 3 as well. Okay. The other thing I've done, just because that was going to get a little bit complicated, was I wrote it left to right as a division statement as well. So you'll notice that this guy here is my top where I've changed my 1 to 3 over 3. And then I said divide, that's for this big line here. And then the bottom, I called my 1 3 over 3. So I end up with 3 minus root 3 all over 3. Okay, so this is where I am. I'm out of room on this slide, so I'm going to switch the slides here in a second. But when I divide fractions, I multiply by the reciprocal. So I'm going to change this to multiplication and then just flip the second fraction. So I'm looking at this guy. So negative 3 minus root 3 all over 3 times 3 over 3 minus root 3. Most of you are going to see right away there, my 3's here will divide each other out. And that simplifies to negative 3 minus root 3 all over 3 minus root 3. Now, take a look at the question again. It said it was in the form negative a minus root b. I am not in this form at the moment. Now, this is technically still the correct answer. What happens is this is not the rationalized answer, and you do have to rationalize here because you were asked to write it in this form. So remember, when you go to rationalize, you're going to multiply by the conjugate of the bottom. So this has to get multiplied by 3 plus root 3 over 3 plus root 3. On the top, we're going to FOIL that out. So I've got negative 3 times 3 is negative 9. Negative 3 times root 3 is negative 3 root 3. I got another negative 3 root 3 here from the insides. And then here I've got minus 3. On the bottom, I'm going to have a difference of squares, so that ends up being 9 minus 3. Going to clean it up a bit. Negative 9 minus 3 is negative 12. Negative 3 root 3 minus 3 root 3 would be negative 6 root 3, and then I'd have a 6 on the bottom. So currently I'm at negative 12 minus 6 root 3 all over 6. Both of these terms can be divided by 6, so that ends up being negative 2 minus root 3. Now I see that that is in the form of negative a minus root b, so I'm done, and I'm going to state what a and b are. Be careful with this. A common mistake, just because we're going too fast and we're not paying attention, is we conclude that a is negative 2 because we see negative 2 here. But what you want to remember is in the format you were given, it said negative a, so that negative is already taken care of. The value of a here, the way this is written, the value of a is 2, and the value of b is 3. Okay, awesome. All right, next question. If sine of alpha is 5 over 13 and alpha is between pi over 2 and pi, cos of beta is negative 4 over 5 and beta is between pi over 2 and pi, determine the exact value of the sine of alpha minus beta. This is one of those questions where you can legit look at this and say, oh, this is all Greek to me. And it really is. It's all Greek. Huh. Okay, sorry, bad joke. Okay, what to do? Well, I don't know, but I know that I'm asked to do sine of alpha minus beta. And I know that that's an identity. So you might as well just start there. Always start with something that you know how to do. Okay, sine of alpha minus beta is sine of alpha cos of beta minus cos of alpha cos of alpha sine of beta. I did no thought there. I looked at my formula sheet and I said, okay, I'm just going to write it down because I don't know what else to do. Now, that breaks it down into 4 different ratios. Do you know what the sine of alpha is? Yes, you do. You were told that in the question. Sine of alpha is 5 over 13. Do you know what the cos of beta is? Yes, you do. You were told that in the question. So cos of beta is negative 4 over 5. So hey, we're not bad here. I already know half of the ratios I need to. It's the second half of this identity that presents a little bit of a problem to us. I don't know what the cos of alpha is, and I don't know what the sine of beta is. And so here's where I have to do a little bit more digging. If I know what the sine of alpha is, and I know what quadrant I'm in, that would actually give me the ability to draw an angle in standard position, drop a perpendicular. If I know sine, I know the opposite and the hypotenuse of that little triangle that I do with the reference angle. All of this should start sounding familiar because these are the things that we were doing right at the beginning of trig when we were talking about reference angles and angles in standard position. Okay, so that's actually what we have to do here. So what quadrant am I in? Actually, for both of them, I'm in the same quadrant, because if you look at this guy, alpha was between pi over 2 and pi, and beta was between pi over 2 and pi. You want to read those carefully because they don't actually have to be in the same quadrant in order for you to be able to do a question like this. So always establish what quadrant each separate angle is in first. You're going to want to draw a different picture for each angle. In this case, both of them are going to be in quadrant 2 for this guy. So I start with alpha. I know that the sine of alpha, which is opposite over hypotenuse, will give me the 5 over 13. I'm going to Pythag my way to the base. 13 is the hypotenuse, so I end up with 169 minus 25, which gives me 144. The square root of 144 is 12. Because of the quadrant that I'm in here, it will be negative. Okay, then I take a look at my next guy. B, I knew the cos of B was negative 4 over 5, so that tells me that the adjacent is negative 4 and the hypotenuse is 5. Again, for this guy, I'm going to end up going 25 minus 16, which is 9, and that tells me that the opposite of this would have to be 3, the square root of 9. So now I know that the cos of alpha is negative 12 over 13, and I know that the sine of beta is 3 over 5. So I add those in, and now I can just do the math on this. 5 times 4, that's going to be negative 20 on the top. 13 times 5 is 65. Here I've got 12 times 3, which is negative 36 on the top, and 65. So I end up with negative 20 over 65 minus negative 36 over 65. And that gives me 16 over 65. So the ratio of alpha minus beta here is 16 over 65. Okay. Awesome. Last question. Simplify sine of 160 cos 20 plus cos 160 sine of 20. Now, at first, this looks like a really confusing question, but what I want you to do is take a step back and say, what do I see here? And it might make things a little easier if you just said, hey, let's just call 160 A for a sec. Okay, and let's just call 20 B for a sec. And then let's see what I've got here. I've got sine of A cos of B plus cos of A sine of B. That is a trigonometric identity. That is the sine of A plus B. So if A is 160 and cos is 20, I'm looking at the sine of 160 plus 20, which is 180. So the sine of 180 is 0. So once you see that, the question actually isn't as complicated as perhaps it looked at the very beginning. Okay? All right. So that's where I stop and you keep going with some of your homework. This is your goal for, let me just take those drawings off for you. This is your goal for sum and difference identities. And then next up, the next lesson we're going to deal with is double angle identities, which is actually going to take you through the last third of these identities. So after tomorrow's lesson, we'll have gone through all the identities that you have to go through. Okay, so have fun. Make sure you ask lots of questions. Make sure you give yourself lots of time to process some of this stuff that's happening. Okay, you can do it. Take care, guys.